I'm still waiting. Oh, okay. Okay, a very good morning to all of you. So our topic for this week is binomial expansion. Binomial expansion. So we know x plus y bracket square is equals to x squared plus 2xy plus y squared. So in order to look for x plus y bracket cube, so we will take x plus y bracket square multiply by x plus y. So when we expand, it will become x cubed plus 3x square y plus 3xy square plus y cubed. So the sum of this x cubed plus 3x square y plus 3xy square plus y cubed is called binomial expansion of x plus y bracket cube. So if we further multiply x plus y, uh, we will get this some sort of a pattern. So this is power to 0 definitely will equals to 1. X plus y power 1, x plus y power to 2 or square will be x squared plus 2xy plus y squared. Okay, so if we go further, x plus y bracket power to 4, it will be equals to x power to 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the power of 4. Okay, so this is binomial expansion. Okay, if we try to abstract the coefficient, say this one, the first one, this is actually is 1x plus 1y. So the coefficient is 1, 1. Okay, so if a bracket square, it will be 1 to 1. So we will write 1 to 1. Eventually, we will get some sort of a pattern. So you can see from here 1, 1, 1, 1 to 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is power to 4. So as you can see, 1 plus 3 is actually 4, right? 3 plus 3 is actually 6. 3 plus 1 actually is a 4. So this is the pattern. The triangular array, so this is the triangular array of the coefficient for the binomial expansion is actually called Pascal triangle. So this is one of the easier way to get the coefficient for the binomial expansions, but only with a small power. Okay, but only with for smaller power lah. For larger power, we should use a factorial notation. So on the next slide, we are going to learn about factorial notation. Factorial notation. So what is a factorial notation? So factorial notation, usually we write n, can you see, n factorial. So if n is a positive integer, n factorial is defined to be the product of all of the positive integer from 1 until n terms. So let's say example 3 factorial. So this will be 3 times 2 times 1 equals to 6. So 5 factorials will be 5 times 4 times 3 times 2 times 1 equals to 120. Okay, so this is a factorial. So if we, let's say if we have something like 7 factorial divided by 4 factorial and 3 factorial, so this will be equals to 7 times 6 times 5 4 3 2 1 divided by 4 3 2 1, and again is another set 3 2 1. So by cancelling off, final, finally the answer is 7 times 5 35. So this is factorial. Okay, so how to apply the factorial into binomial expansion? Okay, so as you can see from here, the coefficients for x to the power of 4, so this is actually 4 factorials by 4 factorials times 0 factorials. So the answer is 1. So the coefficient for the first this one, the first one is actually is 1. So this is 4. Okay, as you can see is 4. So 4 factorials divided by 3 factorials and 1 factorials. So the coefficient is 4. So the third one, 4 factorials by 2 factorials and 2 factorials. Okay, so 4 3 2 1 divided by 2 times 2. So the coefficient is 6. So this one is 6. The coefficient is 6. Okay, so this is factorial. So if we see further, so this is the, sorry, this is the, you can see from the previous one, this is the 1 2 3 4. Okay, the fourth one. So it's 4 and 1. Okay, then come to the binomial theorem. In the expansions of x plus y bracket n for a positive integer, and there are n plus 1 terms given by the following formula. So this formula, I think you can find, you can get it from your rumus. Rumus. So the formula is n factorials divided by n factorials times 0 factorials. So the y is actually power to 0 is equals to 1. Okay, and then plus n factorials, n minus 1 factorials, and 1 factorials. Okay, this is actually 1. N minus 1. Okay, the next one, n factorials divided by n minus 2 factorials and 2 factorials. Okay, and then to the final terms, n factorials, here the x is power to 0, so times n factorials. So this is the n factorials. So this is the general formula for binomial binomial theorem or binomial expansion. So another way of writing the binomial, we can use the notation n combine uh, the combination formula. So we can write in the if this is the notation, then we can write in this form: n factorial over n minus r factorial multiply r factorial. Okay, so this is another notation in writing the general formula for binomial. So as you can see from here, so the first one is n 0, n1, n2, and the last term is nn. Okay, so x to the power of n, x to the power of n minus 1, and y, x to the powers of n minus 2 and y squared, and then to the last term, y to the power of n. So we know that this could be equals to the this one n factorial over n minus r bracket factorial times r factorial. So this is n. We read this by n combine r combination. This is combination. This is a combinations formula. So as you can see from here, n choose 0 x to the power of n. So this is another way of writing the general formula lah. N choose 1, n choose 2, and then n choose n. Okay, so this is another way of writing the formula for binomial. Okay, example. X plus y bracket power to 9. So if we are using okay, let's check what formula we should use. Okay, never mind. Let's say we are using okay, I write the formula here. X plus y equals to n factorial 0 factorial xn plus n factorial n minus 1 factorial 1 factorial x n minus 1 y plus so I just skip the one n factorial 0 factorial n factorial y to the power of n. So by looking at this formula, so we can write in this form. So 9 factorial divided by 9 factorials, okay, and 0 factorials x to the power of 9. So this is the first one, first term. And then the second terms will be 9 factorials. So 9 minus 1, 8, and the y power of 1, 1 factorials. The third one will be 9 factorials, 9 minus 2, 7, and then this one y power to 2, 2 factorials. So um, we get the first three terms will be equals to, definitely you can expand further you can expand further. So if you look at the first three terms, it will be equals to x squared plus 9 x to the power of 8 y plus 36 x to the power of 7 multiples of y squared, and then so on.